explain you the chapter ordinary differential equation topic. In this we have so many definitions. First we are going to learn some important definitions that are based on problems also. So before going to identify the examples or problems in your exams, we have to perfectly learn definitions first. Okay, first definition is differential equation. From the topic ordinary differential equation, we have to learn differential equation. An equation involving differentials or one dependent variable and its derivatives with respect to one or more independent variables. For example, I have written already three examples here. See dv by ds, okay, ds, dr by dt. Okay, dv by dt equal to v here. This is one differential equation. In this we have this s and t are derivatives which are independent. These are independent. And this numerator we have v. With respect to v we have dependence. Okay, we have only one dependent. Okay, we have two independent variables. So an equation involving differentials or one dependent variable and its derivatives with respect to one or more independent variables. Okay, we can have one or more, and more than two. We have here another example, that is d square u by dx square plus d square u by dy square plus d square u by dz square equal to 0. In this we have u is only one dependent variable in this equation and three variables are there, different variables that are independent variable. So this equation is in the form of differential equation form. So second also we have only one independent variable, that is x only, and y is the dependent variable. So we can have one or more than one independent variables in the equation. So we can identify with this definition that this is a differential equation or not. Okay, how many different types of differential equations are there? So we have two types of differential equations in ordinary differential equation. They are ODE, ordinary differential equation, and partial differential equation. First, in this video we can learn what is ordinary ODE and PDE. In short form, ODE we can also called as PDE. Okay, now in ODE, what is ordinary differential equation? How to identify the differential equation is ODE or PDE. So if the derivatives in the equation have reference to only a single independent variable. First of all, we have to know what is independent and dependent. So denominator the variables are independent and numerator the variable is dependent. So in the differential equation, reference to only a single independent variable. Okay, single means only one variable we should have. Okay, in this differential equation I have written two examples here. Okay, here dy by dx whole cube is there, dy by dx whole square plus 4y equal to sin x is there, for example. In this, x is independent variable, here only one independent variable and here one dependent variable. So ODE means only single independent variable we must have. Okay, so only one variable, so that's why we can call it as ODE, ordinary differential equation. So only one variable in the denominator, that is x, is there. Okay, for example, this is the general formation of ordinary differential equation, that is x comma y dy by dx d square by dx square and so on dn by dny by dx power n, okay, equal to 0. So this is the general form of ordinary differential equation. Okay, we must have only one single independent variable in the equation, that is in denominator. Okay, now PD is the partial differential equation. If the derivatives involving more than one independent variables is PDE. More than, here what is that? More than, we have to observe that more than is there, more than one. So here only a single independent variable and more than independent variables, we call it is equation is partial differential equations. Okay, here examples I have written already, that are d square u by dx square, d square u by dy square plus d square u by dz square. Here how many independent variables are there in this equation? Three independent variables. Here what is the definition? More than one independent variable means one, not one, more than one, it should be more than one. So here dependent variables, we don't have to care about dependent variables, we have to observe only independent variables. So x y z, these are three independent variables, so this is partial differential equation. In this we have s and t are two independent variables, so this is also partial differential equation. And now what is order of the differential equation? How to identify the order of the differential equation given in exam? Okay, so these are basic important topics I am written here, so please watch complete video so that you can identify what is ODE, what is PD, which is what is the order of the given equation. Okay, let us know the order. How? In this equation, d square y by dx square plus x into dy by dx plus equal to sin x is given. So now first let us see how to find the order of the given equation. So order of the highest order derivatives. Here what is the main point we have to observe here? Highest order derivatives means here derivatives highest order we have to see. Here dy is there, d square is there. So highest order is 2 is there. So then the equation we have order is 2. So we have to count that order which have highest order derivative. The derivative is d square is there. Therefore the order is also 2 is. 2 is the order of this differential equation. Now here d square y by dx square, dy by dx whole cube is there equal to x. We have to see here, look at this, d square is there. So we have to see here, this is the highest order of this differential equation. Okay, so now the highest order derivative is 2 here, d square. So this is only the order of this equation. So order is 2 here. In this equation also 2 is the order. Now let us see here degree of the differential equation. How to find out the degree of the given differential equation? Let f is the form of general form is x y y dash y power, so on y power n equal to 0. Be a differential equation of order n. If the given differential equation is a polynomial in y power n, then the highest degree of y power n is the degree of the differential equation. So let us see how to find out the degree of the differential equation. Why I have written here for example here 1 plus x square dy by dx whole square is there plus 2xy dy by dx plus 1 minus y whole square equal to 0. Here see highest degree of y power n. See here dy by dx plus 2xy dy by dx 1 minus y whole square. So highest degree is what? 1 only. Highest degree of the derivative is 1. So here what? Whole power 2 is there. Degree of polynomial 2. Here is the order. This one is the order. This one is 1 is the order. Then 2 is the highest degree. Whole power is there, no? That is the power of n. N is equal to what? 2. So degree is 2. Now in this example, so see here the difference of finding degree. Here d square y whole square by dx square is there, and d is y whole square by dx whole square whole cube is there. Now highest degree is what? D square. Okay, here is 1 only. Highest order is 1. Now here highest order is 2. Then that whole power n is how much? 2. So that n equal to 2, no? That is the degree. Okay, 2 is the degree of this differential equation. Now here see, let us see this d cube by x, d cube x by dt square and d square. In this highest derivative is what? What is the highest derivative in this? D cube. Okay, d cube is the highest derivative. Okay, now in this also we can learn very easily how to see here. Okay, wait. In this d cube x by order is what? Here the highest derivative is what? 3. So we are writing order is 3. Okay. Now let us see degree. So highest degree is what? 3 here. So see here the power of derivative. What is the power here? 1. So the degree is 1. N equal to how much? Y is the polynomial, that is d power n is there. So n is what here? 1. So degree is 1 here. So like this we have to find out the degree and order of the every differential equation. Okay. So we have to find out the highest derivative power. Okay. Here highest derivative is 3. 3 is the order. And power is what? 1. That is n here. Nothing is there. So nothing is there. We have to write 1. So degree is 1 in this differential equation. So very easy to find out the degree and order of the differential equation. Now you have learned degree and order of the differential equation, and what is differential equation and what is partial differential equation. Now let us know first order differential equation. An equation of the form dy by dx equal to f of x comma y is called first order differential equation, and it can be in the form of m of x comma y dx plus n of x comma y dy equal to 0. This can be solved in 3 methods or 4 methods are there. Sorry, 4 methods are there to find out the first order differential equations. Okay, hello everyone. So welcome back to my channel. So in this video we are going to learn the first order differential equation with example also. In this I am going to explain you the variable separable method by one example. Okay, please watch complete video so that you can understand the ordinary differential equation variable separable method also. So please subscribe my channel for more updates and for more videos on math topics. Okay, variable in these 4 methods, variable separable method is there, homogeneous equation and reducible to homogeneous form, exact equations and linear equations, and Bernoulli's form is there. 4 different methods we are going to differentiate in this first order differential equation. So first method is variable separable method. If we have given dy by dx equal to f of x comma y, then m dx plus n dy is the form. Then how to solve? By using variable separable, we can solve the differential equation. Okay, if the dy by dx equal to f of x comma y is given, can be expressed in the form dy by dx equal to f of x by f of y, or dy by dx into f equal to f of x into g of y form. If you have given in these two forms, we can use variable separable method easily. Okay, here f or g are continuous functions of a single variable and is said to be the form of variable separable. Now here working rule of variable separable. How to apply this rule? The given equation is in the form of dy by dx equal to f of x by g of x. Okay, now can be written in the form of separating variables as f of x dx, and cross multiplicating we have to separate the variables of same form, that is y form. Y variable is there, we have to go with dy, and f of x there we have to take it to dx. Okay, so f of x dx is equal to g of y and dy. Okay, integrate this equation, we have to get the general solution, that is integration of f of x dx equal to integration of g of y dy plus c or pi of x comma y comma c equal to 0, where c is a constant, arbitrary constant. Okay, this is the general solution of this variable separable form. Okay, so now I am going to solve here the question given, that is solve 1 minus x dy plus 1 minus y dx equal to 0 is the question. So here by seeing only we can say that this is in the variable separable form. We can express it in the form of variable separable form, because here x term is there, here y term is there. So 1 minus x dy equal to, I am taking this to outside, this becomes minus of 1 minus y into dx. Okay, this dy is there, so take it this y term to dy side, 1 minus y. Okay, minus, okay, let us take plus only, so minus as it is, and take this 1 minus x to this side, so 1 by 1 minus x into dx is there. So we have separated by variable separable method, we have separated dy by dx, dy by dx equal to f of x by g of I, like this form, that is dy by y terms and dx by x terms. Okay, like this. Now we have to, what to do now, we have to integrate this form. So next step is what? Integration. Second step is integrate. Okay, integrate now. Integration of 1 by 1 minus y dy is equal to minus of 1 by 1 minus x dx is there. Okay, now this is in the integration form, second step. Now we have to apply the general solution. We have to, like this, f of x dx equal to g of y dy plus c. Now here we have the formula already in the integration. We have one formula. What is that formula? If you know the formula, please apply the formula. Please, whenever you have to solve the problems, we have to be perfect in formulas. Okay, the formula applying is integration of a minus x dx equal to minus of log a minus x plus c. This is the formula I am going to apply in this problem. Okay, now here what is the step here? 1 by 1 minus y dy is there. So applying this formula, here we have 1 is in the place of a and x is here. Why? Here also x form is there. In place of 1 we have a here in formula. So apply this formula in this side, left side. So we can get minus log of 1 minus y. Okay, here what? Minus already is there, minus of log 1 minus x is there, so 1 minus x plus c. Okay, constant is c, so minus of log 1 minus y equal to minus of minus plus log 1 minus x plus c. Okay, so this log of 1 minus x I am taking to this side, becomes minus of log 1 minus x. Okay, let us write here minus of log 1 minus y, log 1 minus x is there, plus c is there. Okay, now I am taking this log to this side, what it becomes? Minus log of 1 minus y, this comes to this side, minus log of 1 minus x equal to log c. Okay, now here what? Minus, take out minus common, log of 1 minus y plus log of 1 minus x, okay, is equal to log c. So this minus goes to this side, log of 1 minus y and 1 minus x, it becomes what? Log of 1 minus y plus log of 1 and next step I am writing clearly each and every step. This becomes log of c minus log c. It is already a constant, so log of a, log a plus log b. So log a plus log b is ab. So this can be written as 1 minus y, 1 minus x equal to c. So like this we have to solve the differential equation. This is what we have applied the formula in this and we have applied the variable separable method given in the question. We have, if given in the question, we have to apply by using, we have to solve variable separable. If not, we have to observe the given question like this: y terms and x terms, we have to separate y terms, x terms to differentiate easily. After that separating, we have to apply the second rule, that is second rule, integration. So generally the general solution is, we have integration. Okay, now the general solution is what? 1 minus y into 1 minus x equal to c. After integration we get the solution. So like this we have to solve the differential equation. So next video I will come with homogeneous equation second method, and third method exact equation, fourth method linear equation. So in next video with next important questions. Okay, so watch complete video children. So subscribe my channel, like, share and subscribe my channel for more updates, for more tricks and videos on math topics. Okay, in this video we have learned ordinary differential equation. Okay, an equation involving differential one dependent variable and more than one or more independent variables. Okay, first of all we have to know what is dependent variable and what is independent variable in differential equation. In numerator term, that is variable, we call it as dependent variable, and denominator we call it as independent variables. Okay, here two independent variables, only one dependent variable is there. So this is in the form of differential equation. One or more independent variables are there, then we can say that that is in the form of differential equation. Okay, we must have one also, we can have one also, we can also have two or more than three. Here two independent variables, here only one independent variable. In this we have three independent variables. Like this we have to observe the differential equations. There are mainly two important differential equations: ordinary and partial differential equations. In this video we have learnt only ordinary differential equation, separable, variable separable, that is in four methods we are going to apply for first order differential equation. That is four method. I have explained you variable separable very easily. Based on variable separable, many examples are there. We have to do like this only, we have to separate the terms and we have to integrate that. So that's it, we have to integrate, and that is the general solution of this question. Okay, like this we have to solve very easily. So all the best for your exams, and please follow and subscribe my channel for more updates on math topics. So all the best for your exams. Thank you for watching. Thank you. Bye bye.